So hi everyone, my name is Eliza May Guzman and I'm here to discuss to you the relationship of meteoroids, meteors, and meteorites. So here is the overview of this topic. Here is a picture that describes the relationship of these three. The term meteoroid is used when it is still located here outside the Earth's atmosphere. And when it reaches the Earth's atmosphere, it can now be called as meteor. When meteoroids survive a trip through the Earth's atmosphere and hit this ground, it can now be called as meteorite. So you have an idea or brief background about this topic. So before we go further, let's first know the objectives of this lesson. First, explain the relationship between a meteoroid, meteor, and meteorite. Second is to describe what happens to a meteoroid as it moves from outer space to the Earth's surface. Third is to describe the three different types of meteorite. And lastly is to explore the importance and impacts of meteors, meteoroids, and meteorites in our daily living. Our solar system not only consists of planets and satellites, but also many other objects such as asteroids, comets, and meteoroids. The space between our planets is populated by billions of small particles which orbit around the Sun. They are called meteoroids, and according to the International Astronomical Union, they are smaller than a meter in diameter. So our first topic is meteoroids. Meteoroids are what we call space rocks that range in size from dust grains to small asteroids. This term only applies when they are in space. Most are pieces of other larger bodies that have been broken or blasted off. Some come from comets, others from asteroids, and some even come from the moon and other planets. Some meteoroids are rocky, while others are metallic, or combination of rock and metal. Next is a meteor is the flash of light that we see in the night sky, when a small chunk of interplanetary debris burns up as it passes through our atmosphere, also known as shooting star. Most meteoroids that enter the Earth's atmosphere are so small that they vaporize completely and never reach the planet's surface. These meteors come from meteoroids. There are three main sources of meteoroids. Many are left over from the dust that form the solar system. Others are fragments of asteroids broken off in collisions. Huge meteor showers caused many meteoroids entering the atmosphere in one go are caused by comets. They occur when the Earth's atmosphere passes through a stream of small particles left behind in comets' day. So what do we mean by a meteor shower? Scientists estimate that about 48.5 tons or 44,000 kilograms of meteoritic material falls on the Earth each day. Almost all the material is vaporized in Earth's atmosphere, leaving a bright trail fondly called shooting star. Several meteors per hour can usually be seen on any given night. When there are lots more meteors, you're watching a meteor shower. Some meteor showers occur annually or at regular intervals as the Earth passes through the trail of dusty debris left by a comet and in a few cases asteroid. Meteor showers are usually named after a star or constellation that is close to where the meteors appear to originate in the sky. Perhaps the most famous are the Perseids, which peak around August 12 every year. So next is the topic about meteorite. In simplest terms, a meteorite is rock that falls to Earth from space. Meteorites are rocks, but they are not like Earth's rock. Most are far older and they provide some of the only samples we have from other worlds, other planets, asteroids, and possibly comets in our solar system. Some meteorites even contain tiny particles that formed around other stars that existed before our Sun. Meteorites come from asteroids, planets, moon, and comets. So meteorite can come from asteroids. The vast majority of meteorites are fragments of shattered asteroids. Asteroids are rocky bodies found mostly in the asteroid belt between Mars and Jupiter. Jupiter is the largest planet in our solar system, and its gravity is very strong. Asteroids, which are much smaller than planets, are sometimes pulled out of the asteroid belt by the force of Jupiter's gravity. Many of these asteroids then travel toward the inner solar system, where they can collide with Earth. Next is planets. A small number of meteorites are pieces of rock from the surfaces of other planets. These fragments were likely blasted off planets when they were hit by a large asteroid or comet. People have found meteorites that are definitely from the planet Mars. Next is the Moon. The most famous moon rocks are those collected by astronauts who walk on the Moon, but small pieces of the Moon also occasionally reach Earth as meteorites, such as lunar meteorite, are identical in composition to the astronauts' moon rocks, although they come from different locations, possibly even from the far side of the Moon, which never faced Earth. And lastly, comets. Meteorites might also come from comets. Made of dust, rocks, and ices, comets are typically found in the outer reaches of our solar system, beyond the orbit of the planet Neptune. Scientists have identified several meteorites that may be fragments of the rocky cores of comets. We also have these types of meteorites. These are the iron meteorites, stony iron meteorites, and the stony meteorites. So first, iron meteorite. Most iron meteorites are thought to be the cores of asteroids that melted early in their history. They consist mainly of iron-nickel metal with small amounts of sulfide and carbide minerals. There can be wide variation in the texture and mix of minerals present within iron meteorites, which will produce many groups and subtypes. So, this picture is an iron meteorite cut and etched with acid to reveal its crystal structure. Next is stony iron meteorite. Stony iron meteorite are any meteorite containing substantial amounts of both rocky material or silicates and nickel iron metal. Such meteorites, which are often called stony irons, are an intermediate type between the two more common types, stony meteorites and iron meteorites. In specimens of one common type of stony iron, known as pallasites, the nickel iron is coherent mass enclosing separated stony parts. The material that makes up pallasites probably formed after melting and differentiation of their parent asteroid at the interfere between the nickel iron metal core and surrounding silicate mantle. So, this picture is called the Salta or Aymilac stony iron meteorite, found in Chile in 1822, shown in sewed, polished, and etched interior section. Classified as a pallasite, it is composed of dark crystals of a silicate mineral olivine and a sponge-like network of nickel-iron alloy, Smithsonian Institution. And next is the stony meteorites. The majority of meteorites found are stony meteorites consisting mostly of silicate minerals. There are two types of stony meteorites. First is the chondrites. Chondrites have distinctive appearance made from droplets of silicate minerals mixed with small grains of sulfides and iron-nickel metal. Their millimeter-sized granules give chondrites their name from the Greek chondres, meaning sand grains. There are many varieties of chondrite with differences in mineralogy relating to the type of asteroid the meteorite come from. Chondrites are the material from which the solar system formed. They have been little changed compared with rocks from larger planets which have been subjected to geological activity. Chondrites can tell us a lot about how the solar system formed. Next is the achondrites. Achondrites include meteorites from asteroids, Mars, and the Moon. They are igneous, meaning at some point they were melted into magma. When magma cools and crystallizes, it creates concentric layered structure. This process is known as the igneous differentiation. The rocky planets Mercury, Venus, Earth, and Mars were formed in this way, giving them planetary crust, mantle, and cores. Achondrites can tell us a lot about the internal structure and the formation of the planets, including our own. So, let's now move to the meteorite impacts. Large fast-moving asteroids or other bodies can hit the Earth, the Moon, or other planets with such force that they can make huge craters. The Moon has millions of craters, revealing how often such bodies enter our planetary neighborhood. The surface of Earth would also have been covered with craters, but most have been disappeared because of geologic changes of the Earth's surface. Nevertheless, we know the Earth has occasionally been hit by large meteorites and undoubtedly will be stuck again in the future. So what can meteorite teach us? By studying meteorites, we can learn details about how our solar system evolved into the sun and planets of today, and how meteorite impacts could affect our future. The most interesting aspect of meteorite might seem to be its dramatic fall to Earth, often a blazing fireball, but scientists spend their careers studying meteorites because they contain a record of our solar system history going back some 4.6 billion years ago. So this topic is very much important for us to learn in order to be enlightened and make us understand the world we are living. So I hope you learned something on this topic. Thank you for listening.